Hello, welcome back to our channel. We continued our series matrices. We had done a first video, that is an introduction to matrices, where we covered addition and subtraction of matrices. We also looked at some of the definition of the terms used in matrices and also the definition of a matrix. And we said that a matrix is an ordered rectangular array of numbers enclosed in a parenthesis. We also said that we denote matrices using a capital letter. Just before we go to today's main content, let's look at some of the properties that we drew from matrix addition and subtraction. If matrix A, B, and C are three matrices of the same order, then matrix addition is commutative. That is, matrix A plus matrix B will be equal to matrix B plus matrix A. This means that if you take the order A plus B and you interchange to be B plus A, you just get the same result. But for subtraction, commutativity law does not apply. Matrix A minus matrix B will not be equal to matrix B minus matrix A. We also say that matrix addition is associative, which is also not true in matrix subtraction. So for matrix addition to be associative, that is matrix A plus matrix B plus matrix C will be the same as taking matrix B plus matrix C and then you add the sum to matrix A. Or you take matrix A, you add to matrix B, and then take the whole sum, you add to matrix C. It will give you the same result. We also discussed about the zero matrix, and we said that the zero matrix is an additive identity. That is matrix A plus matrix O. Now, the O represents the zero matrix. We discussed that the zero matrix is a matrix that all of its entries are zero. So we denote this matrix using capital letter O. That is from the definition, we said that we denote all matrices using capital letter. So use capital letter O to denote the matrix O. So it will be matrix A plus matrix O will just be the same as matrix O plus matrix A, which will give us matrix A. Now it gives us the same matrix A because the matrix O has zero entries. Now if it has zero entries, if it has all of its entries into zero to be zero, then it means that when you take the first row, first column entry, you add to the first row, first column entry of matrix A, it just give you the entry of matrix A. So all of its entries, when you take from 0, you add to A, it just give you the result of that corresponding entry in A, and you remain with just matrix A. We also noted that matrices are only compatible for addition and subtraction if they are of the same order. That is, you cannot add matrices of two different orders. That is, matrix a 2 by 2 matrix can only be added to a 2 by 2 matrix. A 3 by 3 matrix can only be added to a 3 by 3 matrix. A 1 by n n is the number of columns you can add depending on the order of that matrix. In today's tutorial, we will discuss multiplication of matrices. We will look into two areas, that is multiplication of a matrix by a scalar and multiplication of two matrices. Welcome. If you like our content, please subscribe to our channel so that you don't miss any update. Every time we post new video, be the first to watch. Also share our content, like, and also leave your comments. If you have got any questions, leave it in the comment section and I'll get back to you immediately. If you have any suggestion of any video which lesson you want us to prepare for you, feel free to leave it in our comment section and we'll make sure that we prepare that lesson for you. Welcome. Multiplication of a matrix by a scalar. Multiplication of a matrix by a scalar is done by multiplying each element of the matrix by the scalar. That is, you take every element of the given matrix, you multiply by the scalar. A scalar is any number, a constant number. It can be 1, 2, 3, or a negative value, or even the 0. Given that matrix A is A, B, C, D, is to be multiplied by a scalar alpha. The product will be alpha A, that is alpha multiplied by matrix A. Now matrix A is A, B, C, D. So it will be, we have said, as we have said in the definition here, that you multiply each entry with the scalar. That will be alpha times A, you get alpha A. Alpha times B, you get alpha B. Alpha times C, you get alpha C. And then alpha times D, you get alpha D. So you end up with the matrix alpha A, alpha B, alpha C, and alpha D. Now you have realized that the matrix will just be of the same size as the matrix that you are given. The only thing that changes is the entries. The entries will increase by number of times of the magnitude that the alpha, the constant number, the scalar holds. Example: find the product of P, which is 3, 2, 1, 3, 1, 11, 4, 15, 2, multiplied by 3. So you have been asked to multiply this matrix by 3. It will be 3 times matrix P. Matrix P is 3, 2, 1, the 3 by 3 matrix, 3, 2, 1, 3, 1, 11, 4, 15, 2. This will be the same as 3 times 3, you'll get 9. 3 times 2, you get 6. 3 times 1, you get 3. That will be for the first row. For the second row, it will be 3 times 3, you get 9. 3 times 1, you get 3. And then 3 times 11, you get 33. It gives you the second row of the answer. Now the third row will be 3 times 4 is 12. 3 times 15 is 45. 3 times 2, get 6. Now you end up with a 3 by 3 matrix. So meaning that if you multiply any matrix with any scalar, you just end up with that same matrix. The size will just remain the same. The order will also remain the same. Now for matrix multiplication of two matrices is a bit different from scalar multiplication. Here we use the idea of dot product. Now there is a condition for multiplication of two matrices. The condition is that for two matrices A and B, multiplication is possible if and only if the number of columns in matrix A equals to the number of rows in matrix B. In that case, the matrices are said to be compatible for multiplication. That is, it means that the number of rows for the first matrix, in this case we are multiplying A, B, so it will be matrix A. Then it should be the number of columns in that matrix should be equal to the number of rows in matrix B. If it were BA, the number of columns in B should be equal to the number of rows in A. In that case, then we will say that those two matrices are compatible for multiplication. Consider matrix A, A, B, C, D, E, F, G, H, I, and matrix B, J, K, L, M, P, Q, R, S, T. These two matrices are to multiply to obtain matrix AB. Now the product AB of the two matrices will be given as A times J. That will be A times J. Get AJ for the, we are now dealing with the first entry, the first row, first column of the solution. That will be A times J, AJ. Then plus, now the idea of dot product, plus B times M. It will be plus BM, then plus C times R. Get CR. Then for the second entry, we just use the same row of matrix A now, but we use the second column of matrix B. That will be A times K plus B times P, get BP, plus C times S, get CS. Again, for the first row, third column, we will use the third column of matrix B, but still the first row of matrix A. That will be C. That will be A times L, get AL, B times Q, get BQ, and then plus C times T, get CT. We go now for the second row. The second row, we use the second row of matrix A. That will be D times J. Now we come back to the first row, first column of matrix B. It will be D times J, you get DJ, plus E times M, you get EM, plus F times R, you get FR. Also for the second column, second row, we'll use the second row of matrix A times the second column of matrix B. That will be D times K, you get DK. E plus E times P, you get EP, plus F times S, you get FS. You'll also do this the same thing for the other entry, and you still get, it will give you the that column of that second row. Now for the third column of the solution and for the third row of the solution, we just do as we did for the first and second rows, and you'll end up with a solution like this one. Now let's look at other examples and see now how we use these matrices. Given that P equals to 2, 3, 1, 2, and Q equals to 2, negative 3, 1, negative 2, find PQ. Now we are multiplying matrix P to matrix Q. This will be given as 1, the matrix P, that is 2, 3, 1, 2, multiplied by matrix Q, which is 2, negative 3, 1, negative 2. This will be the same as 2 times 2 plus 3 times 1. You get 4 plus 3. Again, it will be 2 times negative 3 plus 3 times negative 2. That you get negative 6 plus negative 6, which is the same as negative 6 minus negative 6. And then for the second row, it will be 1 times 2. That is 2 plus 2 times 1. It will be 2 plus 2. And then it is 1 times negative 3 plus 2 times negative 2. Get negative 3 plus negative 4, which is the same as negative 3 minus negative 4. Now when you add these together, you have the solution as 4 plus 3 is 7. Negative 6 minus 6, you get negative 12. 2 plus 2, you get 4. And then negative 3 minus 4, you get negative 7. Now, we are also being asked to find QP. Now we multiply in the reverse way. Matrix Q times matrix B. It is still compatible for multiplication. As you can see, the number of rows are 2, and the number of columns here is also 2. So you can multiply. This will be 2 times 2. You get 4 plus negative 3 times 1, you get negative 3, which will get 4 minus 3. Then it will be 2 times 3, you get 6, plus negative 3 times 2, you get negative 6. That will be 6 minus 6. And then it will be 1 times 2, you get 2, plus negative 2 times 1, you get negative 2. You end up with the 2 minus 2. And then 1 times 3, you get 3. And then negative 2 times 2, you get negative 4. You end up with 3 minus 4. When you add them together, it will be 4 minus 3 is 1. 6 minus 6 is 0. 2 minus 2 is 0. And then 3 minus 4 is negative 1. Now, as you can see, the two matrices P times Q and then Q times P are not the same. We have gotten different answers. P times Q was different as compared to Q times P. Now, this is different from matrix addition. As you know, if you are adding, you will just get the same result. Now, what does this tell us? This tells us that matrix multiplication is not commutative. That is, matrix P times matrix Q is not equal to matrix Q times matrix B times matrix P. Now, another thing that we need to know about matrix multiplication is the identity matrix. Now, the identity matrix exists in addition and also in multiplication of matrices. Now, an identity matrix, also known as the unit matrix, is a square matrix whose every element in the leading principal diagonal is 1. Now, the principal diagonal goes in a diagonal way. Starting, it begins with 1. Then every other entries becomes 0 for that column, for that row. Then again, it begins with 0, then 1, and then the same thing. Now, we denote the identity matrix as 1 n times n. Now, n times n is the order of that matrix. So, let's look at an example. Now, an example of an identity matrix is this identity of a 3 by 3 matrix. It is 1 0 0 0 1 0 0, 0, 1. Now as you can see, for the first row, first column, the first entry is 1, but all of the other entries become 0. When you go to the second row, the first entry is 0, then the second entry is 1, and every other entry becomes 0. Then also when the third row, it is 0, 0, and then 1. Now it forms a diagonal. Now this is what we call the principal diagonal. The identity matrix is a multiplicative identity. That is, when you take matrix A, you multiply by the identity matrix. It will just be the same as taking the identity matrix multiplied by A, which will just result to matrix A. For example, consider matrix A 4, 7, 9, 5, and this identity matrix. For each identity matrix, it should also be a 2 by 2 matrix, because matrix A is a 2 by 2 matrix, so we use a 2 by 2 matrix. Now the identity matrix for 2 by 2 matrix is 1, 0, 0, 1. When you multiply A times I, it will be 4, 7, 9, 5 times 1, 0, 0, 1. It will be 4 times 1 plus 7 times 0. Obviously, the 7 times 0 will be 0. It will be 4 plus 0. Get 4. Again, it will be 4 times 0, get 0. Plus 7 times 1, you get 7. It will be just be 0 plus 7, you get 7. Again, it will be 9 times 1, 9. Plus 5 times 0. You get 9 plus 0 is 9. 9 times 0 will be 0, and then 5 times 1 will be 5. It will be 0 plus 5, you get 5. You can see you've gotten 4, 7, 9, 5, which is just the same as matrix A. Now let's do IA, that is identity matrix times matrix A. It will just be the same thing. It will be 1 times 4, you get 4, times 0 times 9, you get 4 plus 0. That will be just be 4. 0 times 7, 0 times 4, you get 0. It will be 1 times 7, you get 7, plus 0 times 5, you get 0. It will be 7 plus 0, you get 7. The same thing will apply in the second row, and you just get the same matrix as matrix A. This shows us that A times I is the same as I times A, which is just the same as matrix A. Another property is associativity in matrix multiplication. So matrix multiplication is associative. That is a property. That is, given matrix 3 matrices A, B, and C, when you take matrix B, you multiply to C, and then you take the product multiplied by matrix A, it will just be the same as taking matrix A, you multiply by matrix B, and then you take that product multiplied to matrix C. Example, consider matrices A, which is 1, 2, 3, 4, multiply, and matrix B is 3, 6, 2, 1, and C is 2, 4, 6, 8. These three matrices are to be multiplied. A times BC, that will be BC is we multiply matrix B to matrix C. So it will be 3 times 2, you get 6, plus 6 times 6 is that 6. When you add them together, you get 42. And then the next one will be 3 times 4, you get 12, plus 6 times 8, you get 48. When you add them together, you get 60. 2 times 2, you get 4, plus 1 times 6 is 6, so 4 plus 6, you get 10. Then 2 times 4 is 8, plus 1 times 8 is 8, so 8 plus 8 is 16. So now this is matrix BC multiplied by matrix A. So it will be A times BC. It will be 1 times 42 is 42, plus 2 plus 2 times 10. 1 times 42, you get 42, plus 2 times 10, you get 20. Sorry for the confusion here, I wrote 90 instead of 20. Maybe if I correct there, it's supposed to be 20. So it is 20. Now it will be 42 plus 20, you get 62. Again, it will be 1 times 60, you get 60, plus 2 times 16 is 32. When you add 60 plus 32, you get 92. Again, it will be 3 times 42 is 126, plus 4 times 10 is 40. When you add 126 plus 40, you get 166. Also, 3 times 60 is 180, plus 4 times 16, which is 64. When you add them together, you get 244. Now this will be matrix A, B, matrix A multiplied by matrix BC. Now let's look at matrix AB multiplied by C. So matrix AB, it will be 1 times 3. You get 3 plus 2 times 2 is 4. When you add them together, you get 7. Again, we have 1 times 6 is 6 plus 2 times 1 is 2. When you add them together, you get 8. Also, it will be 3 times 3, get 9, plus 4 times 2 is 8. 9 plus 8 is 17. And then 3 times 6 is 18, plus 4 times 1 is 4. So 18 plus 3 times 6 is 18, plus 4 times 1, get 4. So when you add them together, get 22. Again, sorry about that also. That here should be 22. So when you multiply matrix AB times C, you will get this matrix. This shows us that when you look at the two solutions, that is, the two matrices are the same. So meaning that the matrix multiplication is associative. That is, A multiplied by BC is the same as AB times C. Let's look at other examples. Now, A and B are two matrices. If A is 1, 2, 4, 3, find B given that A squared equals to A plus B. Now, solution, matrix A is 1, 2, 4, 3. To get matrix A squared, it will be 1, you multiply this matrix by itself. It will be 1 times 1, get 1, 2 times 4 is 8. When you add it, you get 9. 1 times 2 will be 2, plus 2 times 3 is 6. So 2 plus 6 is 8. And then when you multiply the other, it will be 4 times 1 plus 3 times 4. Get 4 plus 12, get 16. Also 4 times 2 is 8, plus 3 times 3 is 9. 4 times 2, it will be 8, plus 3 times 3, you get 9. So it will be 17. There, it should be 17. Now we have to find B. We have now A squared is 9A, 16, 17. So we have to find B. To get B, we let B to be A, B, C, D, because we know that this is a square matrix. So we can put of it matrix B to be of the same size as matrix A. So let B to be A, B, C, D, given that A squared is A plus B. Now what is B? We are using a square matrix, a 2 by 2 matrix, because A is a 2 by 2 matrix, because when we have been told that A squared is A plus B, and we remember in matrix addition we said that matrices are only compatible for addition if they are of the same order. So we use matrix of the same order in adding. So we have A squared is this one, 9, 8, 16, 17, and then we have to find B, which you have let it to be A, B, C, D. Now you take, this is A squared. Now A squared will be equal to A plus B. Now corresponding entries, that will be 1 plus A should give us 9. 1 plus A should give us 9, implying that A is 8. If you move 1 here, it will be 9 plus 1, you get the value of A. Also, B will be equal to 2 plus B is 8. So if 2 plus B is 8, then B will be equal to 6. That will be, when you move 2 to the other side, it will be 8 minus 2. Subtract 2 from both sides. Now let's find C. C will be 4 plus C is 16. So if 4 plus B is 16, then C will be 12. That will be, when you subtract 4 from both sides, it will be 16 minus 4, you get 12. Also for D, it will be 7. 3 plus D, you get 7. So if you 7, you get 17. Sorry. If 17 equals to 3 plus D, then D will be equal to 17 minus 3, which is 14. Bit of correction over there. That will be 17. Now, what will be matrix B? Matrix B consists of A, B, C, D in that order. So the answer will give us the matrix as B equals to A, B, C, D, which will be equal to 8 for A, 6 for B, 12 for C, and then 14 for D. That will be the answer. Now, in another example, given that A equals to 1, 3, 5, 3, B equals to 3, 1, 5, negative 1, and C equals to P, 0, 0, Q, and B equals to BC, determine the value of P and Q. Now, we have been given the condition that matrix A times B is the same as matrix B times C. And we have C has P and Q, so we have to find P and Q, that what are P and Q representing that matrix C. Solution: AB will be multiplying matrix A times B. You'll get it will be 1, 3, 5, 3 times 3, 1, 5, negative 1. You get 18, 12, 32 by following the same procedure, the dot product way. Now BC also, you take matrix B times C, we'll get 3P plus Q, 5Q, then minus Q. When then we have said that AB equals to BC, so we just equate the two matrices together. Now we equate matrix AB, we equate to BC. It will be 18 minus 2, 32 equals to 3P, Q, 5P, and then minus Q. Now the corresponding entries are equal to each other. That is 3P equals to 18, meaning that P will be 18 divided by 3, you get 6. Now also Q is negative 2 equals to Q, which just directly tells us that Q is negative 2. Now also we can also confirm using the other entries. That will be 30 equals to 5P, meaning that P will be 30 divided by 5. When you divide 30 by 5, you'll get 6. And then also we have 2 equals to negative Q. When you divide both sides by negative 1, you get Q as negative 2 also. Now another thing that we should look at is another example. It's an example that involves matrices. We have to find the two variables, the missing variables, that is x and y. Now a matrix A is given by A equals to x0, 5y. We are being asked to determine S squared. So S squared will be, you multiply this matrix by itself. So when you multiply S squared, it will be x squared. That will be, it will be x times 5. It will be x times x, get x squared, plus 0 times 5, you get x squared. Then also it will be x times 0, you get 0, plus 0 times y, you get 0. That will give us a 0 as that entry. Then also 5, it will be 5 times x, you get 5x, plus 5 times plus y times 5, you get 5y. So it will be 5x plus 5y. And then finally it will be 5 times 0, you get 0, plus y times y, you get y squared. Now that is the matrix A squared. Another thing you have been asked that if S squared is 1, 0, 0, 1. Now this is an identity matrix, an identity over 2 by 2 matrix. Determine the possible pairs of values of x and y. So we know that S squared is this one, but we have been asked that the original value of S squared should be 1, 0, 0, 1. So meaning that given the matrix of S squared, we can use that matrix to get, and using the S squared that we made to find the values of the two variables x and y. Now the solution will be, we equate the two matrices. That is from what we did, S squared will be equal to 1, 0, 0, 1. Now corresponding entries are equal to each other. So x squared equals to 1. So if x squared equals to 1, when you find the square root from both sides, when you square root both sides, you get rid of that square root. It will be the square root of 1. Now the square root of 1 will just give us plus or minus 1. Also for y squared, we have y squared equals to 1 also. You can just take this one and it is y squared equals to 1. Also, if you find the square root from both sides to get rid of the power, it will be the square root of y squared, which is just the same as square root of 1, which gives us that y equals to plus or minus 1. We can also confirm this. Since we had x squared, we know that 5x plus 5y gives us 0 from the two matrices, meaning that if we replace x with the positive 1, let's use the positive 1 for example, it will be 5 times 1, you get 5, plus 5y, it should give us 0. So it will be 5x, it will be 5x will be 5 times 1, you get 5, plus 5y, the value of y we don't know, should give us a 0. Now if we move the 5 from the other side to the other side, if we move it to the other side of the equal sign, also, or if we just subtract 5 from both sides, we get that 5y equals to -5. So if 5y equals to -5, 5y equals to -5. So you divide both sides by 5, and you'll get y as -1. Now if you use a negative side, -1 as the value of x, if you replace here with -1, it will be -5. So it will be -5 plus 5y. It will be plus 5y. You get, it should give us 0. So if we add -5 both sides to get rid of the -5 here, you get, it will be 5y equals to -5, which will just give us, will just imply that y is equals to +1, because it will be -5. It will be +5 divided by 5, you get 1. So you can see y is either -1 or y equals to 1. Another example, we are being asked to find n if 14, 7, 3, 11 equals to n times 2, 1, 1, 1 plus 2 times 4, 2, 0, 4. Now we are being asked to find the value of n. So first of all, you multiply n to this matrix. You end up with matrix 14, 7, 3, 1 equals to 2n, that will n times 2, plus n times 1, you get n. N times 1 again, you get n, and then n times 1 is also n, plus 8, 4, 0, 8. Now equate corresponding values. That will be 14 will be equal to 2n plus 8. So it will be 8 moves to the other side, you get 14 minus 8. So it is, if it is 14 minus 8, you get 6. So 2n is 6. So if you divide both sides by 2, if you divide both sides by 2 here, you'll get 3. So n is 3 as your answer. You can also confirm this using the other values. Here you can see n is just directly, that is 0 plus n, you get 3. So n is 3. Also we have that it is 8 plus n is 11. So if 8 plus n gives us 11, what is the value of n? So we can subtract 8 from both sides, or you just move it to the other side of the equal. It becomes subtraction, to be 11 minus 8. So you get, if 11 minus 8 gives us 3, so n is 3. Also you can confirm that with the other value, and you get n as 3. Now another example is given that A 2, 1, that is matrix A 2, 1, 3, B 1, 4, C 2 multiplied by this is a 3 by 1 matrix 3, 1, 2 gives us a 3 by 1 matrix, which is 16, 11, 15. Now this one is compatible. As you can see, the number of columns in matrix A is equal to the number of rows in matrix B. They are all 3. Now we have been asked to find the values of A, B, and C. Now to find the value of A, B, and C, we just multiply. First of all, multiply the two matrices here. We get the result on the left hand side, and then you equate to the right hand side. Now this will be 3a, that will be a times 3, you get 3a, plus 2 times 1 is 2, plus 1 times 2 is 2, so it will be 3a plus 2 plus 2, get 3a plus 4, equates to 16. Now if you equate to 16 here, it will be 4. If 4 moves here, it will be 16 minus 4, you get 12. So it will be 3 divided by, it will be 12 divided by 3 to get the value of a. So it gives us, implying that a equals to 4. So a is 4. For b also, you just multiply again, and you get, it will be b plus 11 equals to 11. Now if you move 11 here, it will just imply that it will be 11 minus 11, which gives B as 0. And then finally for C, if you move 16 to the other side, it will be 15 minus 16, you get negative 1. So C gives us negative 1. So that's what you get. Now we have drawn a few properties of matrix multiplication from what we have been doing, and these are the properties. One is that matrix multiplication is not commutative. That is, matrix P times Q is not equal to matrix Q times P. Also, matrix A times B is not equal to matrix B times A. Matrix multiplication is associative. That is, if you have 3 matrices or more, you can just multiply 2 matrices together first, and then you multiply the other matrix to the product. Also, if for example, if you take matrix B times C, you get matrix BC, and you multiply to matrix A, it will just be the same as taking matrix A multiplied to B, you get AB multiplied by C. Another property is that the identity matrix is a multiplicative identity. That is, matrix A multiplied by the identity matrix I is the same as identity matrix I multiplied by A, which gives us A. The identity matrix is a matrix with the entries that is 1, 0, for example, a 2 by 2 matrix, and then 0, 1. These are an identity matrix of a 2 by 2 matrix. We denote it as I. Now, because it is a 2 by 2 matrix, we denote it as I. We have to indicate it is a 2 by 2. A 2 by 2 matrix. If it's a 3 by 3 matrix, we'll have a 0 here, a 0 here, and also have a 0, 0, 1. That's for 3 by 3 matrix. We have come to the end of our video. Thanks so much for watching. Please like, subscribe, share our content, like our videos. Make sure you click the notification bell so that you don't miss any update anytime we post a new video. In our next video, we are going to discuss about the transpose of a matrix and the determinant of a matrix. Make sure you watch. The link to the previous video, that is Introduction to Matrices, is in our description box. Thanks so much for your support. Keep supporting us that we continue producing more content for you. Thank you and bye.